Good afternoon, ladies and gentlemen, or good morning, depending on when you're watching this. What you're looking at is the 7.3 domain parts of your notes, which will be the first thing we're going to cover in 7.3. Before we get into that, let's start with the bell ringer. What they're asking us to do is, what do the actual solutions to these problems have in common? What could we have done with these problems to help us? So here's the problem, here's the solution. The problem with this is, if you put -7 into that denominator, you will get 1 over 0, which is undefined. Okay? Whereas in 2, we put 4 in here. You get 4 minus 10, and we're going to do the square root of that. We get the square root of -6, or I root 6, which is an imaginary number, which is not real. Okay, so there are a couple rules in math, and this is both of them that you should notice. You cannot divide by 0 in math, and you also can't take the square root of a negative and get a real number. So when we start talking about domain, those are the two big ideas that you're going to be talking about. 1, you can't divide by 0, and 2, we can't do the square root of a negative number or an even root of a negative number, as well. So what we're going to do is swing down here. Excuse me. Today we're going to learn how to find domain of a given function, as well as come up with 2 rules for domain, which we were just talking about. You may pick how you want to learn to find the domain of the function, either algebraically or using a graph. We're going to focus on algebraically in this video, okay, although you could look at a graph on Desmos.com and see where they break. So, what we're going to do is, we're going to find a domain in interval notation. Now, we know we can't do the square root of a negative, so that means that the smallest number that you can do the square root of is when 8x plus 2 is greater than or equal to 0. Okay, we can take the square root of 0, which is 0, and we can take the square root of every positive number. So all we need to know is when this scenario is going to happen, when 8x plus 2 is 0 or larger. So when we go into this, we'll get 8x is greater than or equal to -2. We'll divide the 8 over. I don't have to worry about flipping the sign here because I divided by a positive 8. So x is greater than or equal to -1/4. So you use a bracket when that number is included. -1/4 is the smallest number that will work, and this will go up to positive infinity. If you have a hard time visualizing that, put this answer on a number line. So if this was on a number line, okay, we would have 1/4 would be right here. Okay, -1/4, and the arrow is pointing to the right, so we're greater than that. So you can see that this is the smallest number that works, thus you start with -1/4, and it continues to go to the right up to positive infinity, and that's why we have infinity. This is it. That's your domain, ladies and gentlemen. If you go to 2, notice there's no radicals. However, we cannot divide by 0. So we need to know when this will equal 0. Right? So we saw that for x, we get x is 4. So 4 is the only number that when you plug it in here will give you 0 in the denominator. All the other x values should work just fine. So if you were putting this on a number line again, okay, all numbers would work except for this one. So there'd be a hole at 4, but everything else works. So when we put this in interval notation, you say, okay, what's the smallest number that works? -infinity. In -infinity, we ride the number line until we hit 4. 4 is not included, so it gets a parenthesis. And then we have this right side of 4. So we start from 4 and bigger. So 4 to infinity. And this is your domain for number 2. All right? Going down here to example 3. There is no division. So no division by 0 is possible here. And no square roots of a negative. Okay? So that means everything's going to work. So when you have all real numbers, we're talking -infinity up to infinity. Nothing to break it up. Same thing here. We have no division by x. We don't have to worry about dividing by 0. And we have no square roots or fourth roots. So again, everything works here. Everything that you put in there will give you a value for y, or f of x. Excuse me. And 5. Hey, x is in the bottom, so this is the one where you have to worry about dividing by 0. So you need to know when that's going to happen. Well, once 2x plus 5 equal to 0, 2x equals negative 5, divided by 2, x is equal to negative 5 halves, or 2.5. So, everything works on the number line. So that's negative 2.5, right? So everything works, except for that 1 point value at negative 2.5. So the smallest number works, negative infinity, and negative infinity will work all the way up to negative 2.5. And then we have this right side, which would be negative 2.5. So that's supposed to be a parenthesis there. Okay. Up to positive infinity. So we have negative infinity up to this 2.5 here. Then 2.5 to infinity, negative 2.5 to infinity is here. Okay, 6. No division, no square roots. This is all real numbers. Number 7. Okay, again, can't divide by 0. So we're going to have the following. We want to know when this is equal to 0, because that's the one thing we can't have. So 8 and 13 will make a total of 21. We're going to subtract 21 over. So we get negative 3x equals negative 21. Divide by negative 3, x is 7. So everything's going to work except for this positive number of 7. Okay, so that's what it'll look on a number line again. If we start at negative infinity here, we'll stop at positive 7, pick back up at 7, and have this positive infinity side as well. So that's our solution. Another square root problem. So clearly you can see you have a square root. We know that we cannot have the square root of a negative number, so we need to know where this is 0 or bigger. So I'm going to add 12 over. Get 4x is equal to 12. Divide by 4. You're going to get 3. So on a number line, we have a closed circle at 3, and x is bigger than that. So we're going to start, not a parenthesis because it's a closed circle. We'll start at 3, go to positive infinity. That's our domain. So there's the first state. Take your time. Remember the 2 rules. You can't divide by 0, and you can't take the square root of a negative number. The more you practice it, the more you'll see the consistencies. I'm going to pause here for a second and shift up. All right, to answer number 9, they say look back at the answers for 3, 4, and 6. All those you'll see that there is no x being, no dividing by x, and you'll see no square roots of x. When you don't have any of these 2 situations happening, it's all real numbers. So negative infinity to infinity is what you were looking at there. Because there's no restrictions or no numbers that you can put in there to make the system crash, basically. Okay, so here we go. We're going to be finding domain using a graph. Okay, again, I'm going to do these algebraically, okay? So if we look at the square root of 2x plus 6, remember, we can only take the square roots of 0 and bigger. So we go greater than or equal to 0, and we divide by 2, and again, we're at greater than or equal to negative 3, okay? So if we put that on a number line, we're at negative 3, closed circle, bigger than that. So we have a bracket, negative 3, positive infinity. Number 1's finished. Can't divide by 0, so once x minus 2 equal to 0, only at the x value of 2. So again, we have a hole on the number line at 2, but everything else works. So we start at negative infinity, we go up to 2, take back up to 2, we're going to go to infinity. All right. Second row here. X squared, no division, no square roots. So, just like the one we spoke about, that's all real numbers. Same thing here. Same thing here. Now, in 5, we have 2x plus 4 on the bottom. So that means I can't have 0 in the denominator. So you see cx down there. So we get 2x is equal to negative 4. X is equal to negative 2. So it looks like everything works except for that negative 2 value. And it looks like that. Remember the number line idea, right? So open circle at negative 2, but everything else will work. Number 7, I'll switch over to magenta here. 4x again, minus 12. This has to be 0 or bigger. So 4x greater than or equal to 12. X is greater than or equal to 3. So with a number line, these are always the best ones to do because they require more thinking. So it looks like 3 we're starting at, going to positive infinity. Do not fall asleep on those. Sometimes they get kind of funky. Down here, all right, 12 and 13 make 25. So I'm just going to set that equal to 0. So I'm going to get negative 5x equals negative 25. I'm going to divide by negative 5. So x is 5. So everything works, right, except for that 5. So it's going to look like that. So negative infinity up to 5. We need a u here, or we could be on this side, 5 to infinity. Okay? Shift up again. Give me a second. In number 9, it says, look at the table in your graphing calculator for number 8. So if I do this quick, right, punch this up, we have open. I go 1 divided by negative 5x plus 25. And I go to my table. What you're going to see is there's always going to be a value here, except when you get down here to 8. So when I get to, I'm sorry, it was 5, right? So when we get to 5, see how there's an error here, because that's the only number that didn't work when we solved this is positive 5. The rest of them will have number values there. Not very big, but nonetheless, we still have number values. Okay? So that's what domain lets you say. Look, I have all these values for number 8 except at number 5. What do you notice? 5 is undefined. Just like we said in our domain. This was negative infinity to 5 and 5 to infinity. So everything works, but this 5 in the middle. That's what that means. Now, as far as the rules down here, okay, our rules are, have your answers checked? Yep, do that. Rules for domain. Cannot divide by 0. First rule. Second rule. Cannot take the even root of a negative number. Okay? And that's this section. Again, watch the video as many times as you need. Okay, ask questions. Here to help as always, guys. Good luck.